Now, I need a couple of very willing volunteers. Annie and Dardan. OK, you're going to be the folder, Dardan. You stand there. Annie, come round here. You are going to be the holder. Stand round there. We have a piece of square paper. Could you get your square paper out of your folders? Just tucked in at the back. Now, we've got a big square, OK? So we need 2 people. What I'd like you to do is, first of all, you hold it along the edge, fold the square in half. Nice and easy. Hey, we've made 2 congruent rectangles. Of course we have. Now, the top bit of your square, I want you to fold in half towards the centre. Go on, you can do that. Let's hold that up. We've got to hold it at the centre with our finger, and then we're going to have to fold one of these corners up to the quarter line. Brilliant. OK? See? You've managed it beautifully. Well done. OK, and crease it. OK, so you should have got that. OK? There we go. And now for the second fold. OK? Same thing from the opposite corner. Finger on the centre. Take that opposite corner up. That's it. And stick it onto the quarter line, but over her finger. Well done, and then crease it. Brilliant. OK. Over the centre. Your second fold, do you want to put your finger there? 2 folds, and if you've done it right, you'll have something like a little V in the middle. You'll have a little V. Well done, you've managed those 2 folds brilliantly. Now, we've got like an arrow shape at the moment. So, we're going to fold this corner here, bottom corner, onto this side here, fits right on top of that side there. So we literally just fold it right on top. See if you can have a go at that. So you want to hold that there. You hold it still like that. OK, and you're going to fold that right over onto that side there. OK? Well done, you're guessing what the next fold's going to be. OK. So, we do the same thing to the other side. Like so. All we've got to do, you've done the hard folds now. This corner and this spiky corner of the diamond, we need to fold them in to the centre, both of them. See what shape you get. So, tell you what, you hold this time. Hold it down for her. Annie, brilliant, and fold it and crease it. And then you fold your corner in then, Dardan. Right to there. Fantastic. Let's hold that up. OK, so once we've finished our hexagon, hold them high. Let's see your hexagons. Hey, brilliant. Charlotte, fantastic. Elena, brilliant. Adtha, brilliant. Let's look at the hexagon. It's a regular hexagon. It's a regular hexagon because we've got all sides and all angles are equal. Let's fold it in half. Fold it in half. Hold it up. What shape's that? What shape is it?
Is it a trapezium?
It's a trapezium. It's got 1 pair of parallel sides. Is it still a polygon?
Yeah.
Still a polygon, OK. Now, open your hexagon up and fold it along the other opposite corners to make 3 folds all together. Opposite corner to opposite corner. Crease, that's it. Oof. Thick stuff. OK. So, we have some fold lines on our hexagons. To make this clearer, I'm going to draw my fold lines on. You can see yours quite clearly. Now, my goodness me, we've got 6 triangles, haven't we? What sort of triangles are those? Hands up. Yep.
Equilateral.
You think they're equilateral? What's an equilateral triangle?
When all the sides are the same.
Fantastic. What do the angles in a triangle add up to?
108.
OK, what do you think each angle in an equilateral triangle is equal to? If there's 3 and they're all the same, yeah?
60.
60 degrees. Let's have a think about this. 60 degrees. Well, I think we could be right. 60 degrees, 60 degrees, 60 degrees. Would that make sense? Because we've got a full turn in the middle, haven't we, there? How many degrees in a full turn? 1 full turn. Mohammed?
360.
360 degrees. So 60 plus
60.
plus
60.
plus
60.
plus
60.
plus
60.
equals
360.
60 multiplied by 6 equals
360.
it works. Are all the angles 60 degrees? 6 equilateral triangles. So what is the interior angle of a hexagon? Another clue. What is the interior angle of a hexagon? Tara?
120 degrees.
120 degrees. How do you work that out?
Because that's half an angle is 60 degrees.
Yeah.
So if you double that, it's 120 degrees.
Brilliant. 120 degrees. So the interior, the inside angle of a hexagon, a regular hexagon, is 120 degrees. Welcome to Jonny's Tile Shop. Now then, this is my tile shop. I'm just about to open it. I used to have a coffee business, but that went bust. So, I've got a tile shop, and I want to make my tile shop work. I want it to be successful. I want designs to go on bathroom floors, kitchen floors, maybe some bedrooms. And I want designs made out of regular polygons, just like that hexagon. Now, I've got hexagons, I've got regular quadrilaterals known as? Squares, of course. Here? Triangles. And here, we've got another regular shape. What's that? An octagon. How many sides? 8. OK, now, 1, 2, 3, 4. You're the hexagon builders. Over to your box. You people around the squares. 1, 2, 3, 4 around the triangles. And you crouch around the octagons on the floor. Right then, before we start, I want you to design some patterns. But I want tiles with style. OK, apart from looking stylish, what else do tiles need to do?
You need to have them tessellating.
What does tessellate mean?
Well, tessellate is where you have the same shape over and over again.
Over and over again.
They fit together without any spaces in between.
And they could actually go on forever and ever if they fit together like that. OK, brilliant. So we want shapes, that Ella's told us now, we want shapes to tessellate. So you've got 30 seconds. See if your regular polygons tessellate. You can probably guess already. Hey, this is interesting, octagons. Lovely. Fantastic. And time's up. OK, put your hands up if you're in a group where your shapes tessellated. Squares, do they tessellate?
Yes.
Because they fit together without leaving any
Gaps.
OK. Triangles, do they tessellate?
Yes.
Could they go on forever if you carried on, if you had enough? Fantastic. And octagons, they tessellate, yeah? No. They don't tessellate. They make a pretty pattern, though, don't they? I like them. Right, let's have a look at some of your designs. I'll tell you what, Elena, would you like to put just those 3 hexagons up on the board? Let's see, we'll have William. Can you put 4 of your squares to show how they fit together and make a bigger square? OK, can you put 6 of your triangles up? Just those 6. It's not looking good, though. Yours don't tessellate. I've just bought 1,000 octagon tiles. No, I'm going to throw my octagons away. They don't tessellate. Or put
Squares in between.
a square in between. Interesting. We've got a 90 degree on a square and another 90 degree around the same point. We've got 4 lots of 90. What's 90 times 4? Shout it out.
360.
A full turn. So, 360 degrees is good news for tessellations. The angles around a point, they fit together without any gaps. Fantastic. Now, what's the inside angle of an equilateral triangle? Shout it out to me.
60.
The inside. 60. How many angles here at the centre?
6.
6 times 60, 360. The inside angle of a hexagon. Well, that was 120. And how many are there? 1, 2, 3. So, we could have used the maths to predict that would have happened. Now that we know the conditions for tessellation, in other words, we need the angles at a point where they all meet to add up to
360.
I I reckon we can do something with this octagon. Bring 4 of your octagons up, just 4. Yep, that's it. And arrange them. Go on, Max, you can bring them up. Max had an idea. He said, why don't you put, what was it?
Squares in between.
Like that, a square. Stick one in. Does it fit? Ray, give Max a round of applause. It was his idea. Thanks, Max. That's fantastic. Now, this is really good news because I'm going to use this idea that 360 degrees is the main number for tessellations. If we look at these 3 angles here that join up without leaving any gaps, we've got a 90 degree for the square, have we not? Yeah. What can we say about these other 2 angles here? Ooh, ooh, these 2 angles here. Ooh, Charlotte.
360 degrees, take away 90 degrees, is 270 degrees, and divide that by 2 is 135 degrees.
That is absolutely fantastic. Give her a round of applause. 135 degrees. We've just used maths now to work out the interior angle of an octagon. We have got some different patterns. We have got potentially some different tiling patterns for my tile shop. I'm so excited. I really am. Now then, I'm thinking about this, you know. This is my price list. Here are some equal, regular polygons. And we needed 6 equilateral triangles. That made a tessellation, because 6 times 60 is...
360.
135 plus 135 plus 90 is...
360.
Why is 360 so important?
Because it's a full turn.
Full
Turn.
turn. And that's what happens when shapes fit together. There's no gaps. It's a full turn. It's a full set of shapes around a point. Each point, every point. No gaps. Shapes go on forever. So, who can think of a different combination of numbers or polygons, that's inside angles of these polygons, to add up to 360? A different combination. We've got 2 octagons and a square. What else might add up to 360? Have a little think. What else? You can use as many of any shape as you want. What have you got there?
I've got 2 triangles and 2 hexagons.
Is that why you wrote 60, 60, 120, 120?
Yeah.
2 triangles and 2 hexagons.
Yeah.
Right, will you hold that for me? Okay, will you come up here? Will you hold that to everybody so they can see? Good, stay there. Right, I'm getting excited. 2 triangles, that's 2. 2 hexagons, was it?
Yeah.
Really?
Yeah.
You're cool. Okay. It works! Yes! Well done. Fantastic. Anyone else got a different combination of numbers? Yeah? Something different?
3 triangles and 2 squares.
3 triangles and 2 squares. Brilliant. Up you come. Okay. Adtha.
2 squares, 1 hexagon and 1 triangle.
2 squares, 1 hexagon, 1 triangle. We've not had that, have we? Come on up. Come on up. 2 squares. You might need some more of these. Many apologies. Okay, will that triangle fit in there? Fantastic. Another pattern. Fantastic. Absolutely fantastic. Let's admire these shapes because these patterns are all different designs that tessellate, which means they go on for and they don't leave any gaps. Because the maths tells us, doesn't it?
Yes!
Doesn't it?
Yes!
Doesn't it?
Yes!
360 is a great number, isn't it?
Yes!
We have used maths to help me make money for my tile shop. I think I'm going to have a lot of success. So, give yourselves a round of applause and let's get tiling!